Hey everybody, how are we doing? Whoa, we got everyone here. I see everyone in the chat. Whoa, let's wake up Mewbot. Mewbot, you gotta wake up, man. What you doing? It says stream live, but let's fix that. Let's re-wake up Mewbot here. Mewbot crashed in the roll behind us. Let me catch up on the chat. Could you go over Q3 and 475 homework, especially interpretations? Yep, interpretations. Hey Muhammad, how is project coming? For the positive side, at least you got something. I didn't start it yet. 475 homework is a lot more difficult than 475. Really? Well, yeah. Didn't mean to make it more difficult. 5D is a tough one. Did start planning on assignment 2 today. The earlier the better for me. 2 months ago, I thought taking the jury of the Sarah would be a big idea. Oh no. Yeah, if you're taking 2 classes right now, pretty big. Okay, I'm working on data camp and Shiny during All-Stars. Hope it can help. Yeah, awesome. Okay. It appears that we're in the same group. There you go. Okay. So there we go. CPL in the same. And it was a complete random assignment for the groups. So whatever group you're in, there you go. So say hey to your new group members. Fun stuff coming up this week while we do some stocks in 475. So great stuff. Doing some time series because stocks are amazing time series. I think the first question that was asked was, can we go over Q3 and 475? Let's go over some Q3 475. Let me see if I got 475 open. Assignment 1, BAS 475. Let's go look at some Q3. So feel free to ask those questions. We are streaming right now. Can everyone see me? Trey says hello. I say hello too. And let's go do this. Can you do 474? Yeah, we'll do it next, Jacob. You got it right here. Just ask those questions. As you ask those questions, you can see me. Awesome. Well, I can see you, and you can get some points. And I do label these videos afterwards. Got a good bit of labeling to do today. I see you. We can see you. Thank you so much, Mohammed, right there. Just say hey to me. Talk to me. I'm watching chat at all times. So we got here Q3. We got right here. So intermediate statistics. Run a t-test to see if students have an average GPA greater than 3. Interpret the results below to someone who has not had a statistics course. Your interpretation should help someone without a strong statistics background understand the meaning of your findings. So one of the biggest things we go for in any of our classes is we're not here to say the p-value is this. You know what? I'll even do a few of these. I know people have a lot on their plate right now, so we're just going to toss out a few answers right here. I'm trying to. Sometimes I go a little fast in the car. Sometimes I slow down the car. We're going to do a few of these right here just to help out, knock a few of these out to help people remember their basic stats. So, and then we'll do some more right here. I see for 474, problem 7 right here. So, yeah, awesome. Yeah, start early. Yeah, and you're welcome to start looking at things. Just contact your group. Say, hey, what's a time frame for you? Got it. After searching, I got the 20 minutes. Yeah, but contact me. Say, hey, let's do this right here. But you know what's even better, Muhammad? Watch this. Library. We're going to do it 2 ways here because we can do something 2 ways even better. The t-test and see if students have an average GPA. We can't do it with that. We got to go to subset. Oh, yeah, my brain broke. T.test, something we showed, I think last week. We showed the t-test in 475 last week. Survey 10 GPA, exactly. And so this is what we're doing right here. And see if they have an average GPA greater than 3. So now we want to go alternative. And probably one of the best things you can do, and it's a capital, right? Now it's mad. See, the great thing, it'll correct you. So now we need to interpret these results right here. And mu equals to 3. Great job. We need one more argument, so let's put it in here. Let's go to the last argument of mu equals to 3. And one thing you often want to do when using a function, especially for the first time, is go over here to (t.test). We did mention this last week. We were showing how to use the t-test a little bit. And you can see right here the function and the arguments. We have here a vector of data. Everyone's saying, hey, in the chat, love it. We have here mu is the tested value. And then we have here the, where is it? The alternative, greater than, less than, or two-sided. Two-sided is the default. So we can see how to use this right here. And this basically puts the answer out here. But let's talk about what this result means right here. What does this result mean? Now, we observe a GPA of 3.14. The observed GPA of 3.14 is very close to 3. But you know what's interesting? The difference is what? We're basically answering the question right here. The difference is what? The observed difference right here is the observed mean, I should say, is 3.1489. But what do you notice right here? what do you notice right here? And we should be able to, let me store this as object X, just, an object. And let's go here to X, p-value, and let's say if p-value, this is how you could use this in Shinies, is less than 0.05, then we're going to put right here cat, the result is statistically significant. Unexpected. What did I make? Oh, I used wrong brackets. Curly brackets. There we go. The result is statistically significant. Now, the difference is small, but that's over a large scale of people. This survey 10 has 699 observations in it. So the result is statistically significant is important, but what does that mean we have evidence of? Like, since the result is statistically significant, we were looking for evidence what? So this is the interpretation of it. This is the important part here. Like, it's statistically significant. Yes, the p-value is below 0.05. We didn't need to run code. We could just look at this right here. So we can see the p-value is less than 0.05. If you're using this in apps to return output to tell you if something is or is not statistically significant, we could code it, make it to a new line right here. There we go. Now it's on a separate line. Still runs the same, but, or it doesn't. What have I done? What have I done, everybody? I thought that would. Really? There. You happy? Code? But what does this mean? Who can help us and tell us what this means right here? That the result is statistically significant. What would you say to somebody? We have evidence what? We have evidence for the alternative what? What does it mean that the result is statistically significant? Very important review of 201, 320 right here. That I want everyone to have down. I want everyone to be like, oh, since it... Pretty much, Brayden, you're on the right track right there. You're on the right track. So we do reject the null that the true mean value of GPA is equal to 3. So that's good right there. This means what we observed, the result as high as 3.14 is unlikely by random chance. That's what a p-value is. And these are all right answers. These are all right answers, but we need to refine it a little bit more. What are we telling? Evidence that the alternative is true. That's, yeah. And what is the alternative again? We have evidence that the alternative is true. This is Kayla's on the total right track right here, that we have evidence that the alternative is true. Like, this is strong evidence the alternative is true. We have evidence that the alternative is true. Well, that what we observed, like if we go to direct definitions of p-value, our result of 3.14 or result higher than would be unlikely by random chance, given that the true mean is 3. So we have evidence, Mohammed's getting it right there, we have evidence that the result we observed shows that the true GPA of students is greater than 3. Evidence, the average GPA is greater than 3. Because we started out believing that it's 3, and then what we saw as a result, our result right here of this, had a very unlikely probability of occurring given 3 is true. So if 3 is true, what should we probably observe? Just don't go too stat wordy. If 3 is true, what should we observe? If 3 is the truth. If 3 is true, what should we observe? If 3 is true, what should we observe? What is most likely to observe? If 3 is true, what is most likely to observe? If 3 is true, what is most likely to observe? If 3 is true, given 3 is true, like assuming 3 is the true mean, the most likely thing to observe would be what? If I tell you I bought a dozen donuts, you're right, 3. 3 is the most likely thing to observe. So if we land here, the p-value, whichever way we do it, greater than, less than, not equal to, the p-value will be very what? If 3 is the most likely thing to observe, and we land at 3 or around 3, the p-value will be very what? Because it's going to tell us that this was a likely thing to observe. Landing here, and we're doing a greater than test technically, so we'd have to do something like this. The p-value is going to be very high. Don't worry. This is just practice. This is remembering 201. This is why this assignment exists. Because this is telling us, Timothy and Kayla, you both earned everyone 20 points each. This is telling us that this result around here was what? This result around here was very what? A result close to 3, if 3 is true, a result close to 3 was very what? A lot of words we could use right here, saying like, oh, we got a high p-value. That tells us what we observed was very what, given 3 is true. Expected, likely, very probable, very high probability of observing this. If 3 is true, the result was very likely. Great job, Rose, right there. And then what we did is we landed way over here. And then our p-value is pretty much so small we can't see it, telling us that what we observed was very what? Because there's random chance. Exactly what Kayla's pointing out right here. Like, imagine this. I always like to use the running a mile example. If I tell you I can run a mile in 6 minutes, which would be 360 seconds, and then Brian runs a mile in 361, would you be like, ha, Brian, you're a liar. You can't run a mile in 6 minutes. And I'd be like, well, that's just random variation. Like I run my mile in 6 minutes a lot of time, but there's variation around 6 minutes. Like I'm a 6-minute mile runner. I'm not going to run every mile in exactly 6 minutes. There's random variation that can occur. But if I run my mile in 10 minutes, you're going to be like, that's not very likely given you're a 6-minute mile runner. I reject that you're a 6-minute mile runner because I'd expect something closer to 6 minutes, which is way more probable. But over here at the 10-minute mile mark, yeah, that's just very improbable. And then we'd have evidence that Brian's true mile time is greater than 6 minutes. Is this making a little more sense right here when we talk about like p-values and was our result what we observed likely or unlikely? And p-values are a huge backbone of statistics. This is why even in the upper level classes, I want to make sure we have a review of what p-values are from 201 to 320. Like knowing what a p-value is telling us how likely was what we observed given the null is true. Given Brian runs his mile in 6 minutes, was the observed time right here likely or unlikely? It's got that one. Let's put a cut in the video and we'll do one more of section 3. So we're going to do one more 475 question. 475, if you're in 475, tell me a section 3 question to do. You got like A, B, C, or D. I will do a full A, B, C, or D question for 475. Then we'll do a 474 one. The result we observed shows that every student... we have good evidence. We have good evidence. So always think of it as evidence. We can't say we've proven that the students have a GPA, the true GPA of students is greater than 3. We would just have good evidence at this point to suggest that the true mean GPA of students is greater than 3. So there's good evidence to suggest due to the low p-value. And if you want to talk to a boss about saying p-value, you would say something like, yeah, from our results, it looks like the GPAs are definitely higher than 3. We have good evidence. There's a difference of about 1.4, but we have a big enough sample size that this difference is something that we think exists. It's a real difference. I'm trying to say statistically significant. The result is statistically significant, and it is evidence that the result we observed showed that the average GPA is greater than 3. Yep, Timothy, great job right there. Yep, that's exactly it. We have good evidence to suggest that the real GPA of students, like of all students, not from just this sample, is greater than 3. Like we know what the sample mean is, but we want to know for all students. That's the point of statistics, is to make inferences about the population. So we know the mean of the GPA of sample students was 3.14, but that's evidence right now suggesting that the true mean of all students is higher than 3. One more question from 475. We'll obviously come back and do more questions, but I knew there were some 474 questions also. But what was another 475 one? You're here. You get to pick. It's your call. Tell me one, and I'll do a direct question from the assignment. You just got to be first and be like 3C. Or you could jump and be like 4A. Which one do people want in the office hours? Your call. Be looking at assignment right now. If you're here in office hours checking this out, you get to make the call. So if you're watching this later and you're like, man, I wish they had done this one, your opportunity right now. You get to pick whatever you want. 5D, please. Let's go check it out. Here we go. 5D. Let's go. Put on a little chill music for this. Yeah, 5D. Here we go. 5D. Making predictions. So we need a model. So we're going to jump into a little model making here, a review of 320, helping us out with our R skills, making sure we know how to make models. So make a prediction interval for an individual in the model. One thing I like to do is add R chunks. You can always add an R chunk to wherever you're at. I've got R chunks up here, but you could go and make your own R chunk. You can then search for R chunks doing the following, and we've got a 5D R chunk. I will do this for, because I know there's a lot right now with the app. And this assignment, and this review assignment, a little bit big. I thought it was easier than 474, but from the responses, people think like this is harder. Good move. Okay, so we do have to create. When did I star that out? Never create assignments after getting your teeth done. Create a model picking a quantitative y from the variable from the interaction. Okay, here we go. Create a model predicting a quantitative y variable. so it needs to be a number, from the interaction of a categorical X and a quantitative Y. I do ask, or quantitative X, good. I do ask this, though. Oh, was it? Okay, so yeah. I do ask this, though. Do not use the... So let's put a thing right here. Don't do Brian's example. Don't do Brian's example. Don't do Brian's example. Don't do Brian's example. We see right here, Muhammad's got one right here. Great job, Muhammad. I'm going to slightly work with what Muhammad has. Actually, let me do... Muhammad's got a very similar thing. Great job. Let's go here to Q5 model. This is just the naming convention we're using for something, just storing it into an object. So Q5 model is just the name of the object we're creating. And boom, I love it. Timothy and Connor, you're allowed to drop those things right here. Great job. I keep those in the chat. Sometimes I might say, hey, drop that out of the chat. But no, this is what I want to see. People are making their models. They're making a linear model right here. Let's go look at those variables we got to work with. Here's our variables. And so you can just see them all on the screen. We're going to predict a quantitative Y. So let's just go height right here. The tilde calls the formula format. The formula format is y tilde x comma data equals. Data equals not part of the formula format. But the y tilde x is the formula format. The tilde right here, which is on the upper part of your keyboard. Over here after the escape key is the tilde, or underneath the escape key. So top left side of your keyboard. And let's put in a variable. We don't get the autocomplete right here. You can get the autocomplete if you go to attach. If you want some autocomplete, it's a little bit iffy to do this though, because you'll sometimes have weird things. So now you go here to height, you can alias stuff in the data frame if you do this. But autocomplete is a neat, or the attach is neat because it attaches your vectors to the global data frame. But I would still, you're welcome, Jordan. Jump up to office hours, ask those questions, say, how do you do this? Sometimes I give away answers. Sometimes you got to work on things more. It's all just varying degrees of help. We're here to help. So it's all about putting in that time. And so be careful though. A lot of the functions still require data. I've seen people run the model like this. This is not a full model. It will work, but the way a lot of the remainder functions require a data frame. What am I doing? Think of the visualization function. So visualization would probably get mad if you tried to pass that through. This is not the answer at all to what we're doing right now, but we're just showing how this makes a simple model. So this is just an example here of a simple model. And then the function visualize model, which I'm going to show right here, will create and visualize the model. You can do this with ggplot, a lot of great stuff right there. This is not the model we're looking for. Let's go get the model we're looking for. Star will create an interaction between variables. I was making some time. Oh, ha ha ha. Oh, Kayla, I thought we had an easier one for a second. Why is my model not showing the interactions? What have I done? Oh, I think I just didn't remake the model. What have I done, everybody? What have I done? Should be creating it. Let's go look at the model. We've got here quantitative Y, categorical X, categorical X. I mean, quantitative categorical. Gender's categorical. There's really only handedness and, did I say a 2 level? You can do that one. What have I done? Let's look at the summary. Someone pointed out I basically have to do the whole set. Oh, what? Why are you not creating Q5 model? Okay. Oh, I'm an idiot. Who else notices that? Oh, Philip, 20 points right there. Use mine, Brian. I'm going to use this one right here, Mohammed, so that way people can't use it. I was afraid people might use yours, Mohammed, so I'm going to interpret mine right here and then make sure to not use it. Everyone's pointing out I didn't change. I usually call it just M. So, I mean, we ran out of coffee. No more coffee. We're using the Mario mug today. No more coffee. Brian can't make his models. It just happened I always store that height weight model, so I got really confused. So here we are. Summary of the model. Confirms we have our variables with our interaction. Our interaction is not statistically significant, so we see more like parallel lines. The stronger the interaction, the more the difference in the parallel lines. Let's throw this right here. A little stronger interaction, still not statistically significant. Oh my God. So going back to here, this is such a weak interaction. Let's take a look at some of these questions for this. The pre-workout after 474 before the gym has me going this coffee. I was doing push-ups last night and I felt like a little pain in my side right here. I don't know. Didn't get to do as many push-ups. Sad day. Not good times. So hopefully I can do some push-ups tonight. And then I'll feel happy. It's the only time I feel happy doing push-ups. Make predictions intervals for an individual. Now this is where as people were pointing out, we really have to do a lot right here to get this done. I guess I haven't done VIFs, topic for another video or section. To create predictions, you need to feed it a data frame. This is how the predict function works. The predict function right here takes a model and it makes predictions with a model. But who can tell me what I just made predictions for? Explain what Brian just made predictions for right here. Explain what the predict function just did. Who can explain what Brian just made predictions for? So the predict function takes a model and makes predictions. What did Brian just make predictions for? Isn't it weird? Yep, exactly. Great job, Timothy, right there. Excellent work. Because isn't it weird that we have 699 predictions and we have 699 observations? So these are the predicted heights of individuals who are in this data frame. Like let's just rewind it so we can go to the top easily. The first person right here was predicted to be 5'8". So that is this person right here, who's a female who weighs 160 pounds. She was predicted to be 5'8". So you can see right here all the predictions of the individuals, and this is just every single individual. So what argument do you have to call to make predictions for data that is not inside your data frame? It's almost like it's this kind of data. What argument do you have to call? So to call an argument, we need to do a comma. And what argument do you have to call to make predictions for data that is new to your what you're not using right now? Like, you're for data that's new. And I hate this one, and I want to know why it doesn't do it. It's one of my least favorite arguments, and you'll see why in a second. The reason I hate it is people, I think, we got some answers right there. The reason I hate it is because it doesn't autocomplete. I do not know why it doesn't autocomplete. I just absolutely hate that it doesn't autocomplete. When I contact the person who wrote that, it's like a base R function, I believe. We can look to see where it's at. It's in the stats package. Go talk to the creator of the stat package, whoever managed it, and says, get your autocomplete working. But you can't autocomplete on an argument. Always drives me nuts. So, we don't have a data frame, though. This is something we were covering in 474 today, and I think we did a little in 475 last week, is to call a data frame. And you see Timothy's got his right here. You have to make new data. Yep. So I call sometimes like new data right here. So this is going to be where we have new data. We don't have this object yet. It's probably going to get mad. It says new data not found. Object new data does not exist. So we're going to create it with the data frame argument. The data frame argument right here creates a data frame. We were looking at this a lot today during class. We created that data frame in 474 where we were just putting people's names and stuff. We made the family data frame. So if you remember that from class today, we made the family data frame. We got so much stuff up here. Here's the family data frame, and we were able to create this nice and easily. So let's look at how to create a data frame first. To create a data frame, you need to insert the vectors. How about we just go here and go 1 through 10, and this is not what we want right now, and 11 through 20. How many columns will this data frame have? How many columns will this data frame have? You have one thing too many. Timothy, you're basically on the right track. How many columns will this data frame have? And Timothy, good points. Let me throw 20 points. Timothy, exactly. But how many columns will the data frame I'm creating right here have? Which is the answer for how many I want. It'll have 2. So let's go here to the ND data frame we created and just take a look at it. And does it make sense what this is doing? Does it make sense what it's doing? They have the names of the vector names. But it's making a vector 1 through 10, placing as the first column, making a vector 11 through 20, placing as the second column. So you can see the way I've divided it up, variable 1, variable 2. Now, why do I only need, as I type this code right here, why am I only using this right here? Why am I not using height? Make a prediction for individuals, weight in the model, you call individual prediction interval, and interpret what this means. Okay, let's do this. And so why am I only doing this? It might work with 3. It might work. I wouldn't suggest it. It's probably just not using it. Well, so why do we not need this one right here to make predictions? Why do we not need height to make predictions? This is all great theory. This is all great review of theory. Why would we not need height to make predictions? Think about what height is and why we don't need it to make predictions. Hint, it's what we're predicting. So we don't need height because it's not part of the model. The model itself is only using the variables someone's gender and their weight. Does that make sense right there, Timothy? We won't use height because height's a Y variable, and so we don't use Y variables to make predictions. The X variables are the explanatory variables. Exactly, Braden, right there. Yep. So let's put in individual in the model, and actually we can cheat. I personally put a cheat in this. Let's go here to the first individual, and I'll show you the cheat way of doing it. The first individual is female and has a weight of 160. So if we go here to weight 160 and go female, here's where I put in the cheat method. And let's put in our final arguments, and let's see Brian's quick way of doing this, which you'll be like, no. Okay, there it is right there. But this is an individual who's in our model. What? Don't do that. Good. Refer to future response. That's fine. What you getting mad about? Yeah, there it is. There it is. I really hate that it does that, though. Suppress warnings. You can throw something inside of a suppress warnings. There we go. And there we go. What do you notice about these outputs here? Good. What do you notice about these outputs? So this one used our new data frame of an individual we created, and then it does the prediction interval for an individual. But this one went to the creation of all the predictions and then just took the first row, which was the first person, which literally is the gender of the first individual. Remember, we created a data frame with that individual. They're the same exactly. So you can do this right here. You know what? I'm going to be super nice. Just delete the plus off of this. I'll delete it for you. Hey, helping out in office hours. But that right there will get you. But make sure to specify this is the first individual who goes through the model. Probably a good thing to inform the person of. Maybe even quote their values. Like this person was a female who had a weight of 160. Might be a good thing to inform somebody of, like, this was an individual who had a weight of 160 and was female. They have a predicted value of 61.08 inches to be tall. Or excuse me, I was way wrong. They have a predicted value of 5'8" we're 95% confident right here, because I think we just do classic 95 all the time. Yeah, I didn't change the prediction confidence. We are 95% confident that their height is probably somewhere between 5'1" and 6'3". And I'm converting these to foots and inches, feet and inches. But is this making sense right here? How I can say, like, for this individual, and this is a mass amount of uncertainty. Like, I think this female is probably between about 5'1" to 6'3", and you'd be like, pretty much everybody, Brian. I'd be like, it's a bad model. Doesn't seem that practically significant to say. You could say it's a random person. Yeah, Brian's that height. Chelsea's that height. My sister's that height. My brother's that height. Almost everyone I know is between these heights. And then if you went something crazy, there are individuals who exceed this. We can easily look at the full prediction data frame. This is what's so great. I love it. There's the full prediction. Let's go to interval prediction right here. And let's go to DF. And you can look at, there you go. Let's store to the person with the highest prediction. Wow, somebody was predicted to be 6'6", row 428. So row 428 of the original data frame, this person was predicted to be 6'6". This person is a male who weighs 300, and they're 6'4". Pretty close prediction on them. Is that making sense what's going on right here when I look at these predictions right here and I say, okay, this individual in row 428 was predicted to be 6'6", 0.68 and we're 95% confident they're somewhere between 71.62 inches and 80 ridiculous heights. But it kind of makes sense when you look at the individual right here and you see that they are a male who weighs 305 pounds and they want to weigh 280. That's their goal weight. They're like, man, if I just weighed 280, the world would be perfect. They just need to lose 25 pounds and they'll be so happy. But yeah, Pretty interesting. Is this making sense with the predictions? We're going to do a little 474 now, I think, because I know there's some questions for that. Are there any last questions about this? Yeah. Is it working now, Braden? And thank you, Braden, for working on this early, getting stuck. Then we can just be like, here's how to do this. Here's how to interpret this. We're talking about people right here. Probably go for like an hour and a half. Usually I go for at least an hour, and it just depends. I've gone for 2. Sometimes I've gone for 2.5. It just depends. Friday went a long time because I think I was loopy. We were just working on code. We really didn't get much accomplished. Look at the end of the video. It's like just playing with code. So just ask questions. Sometimes you can preload in a question. I'll do it. Just depends on how busy we are, but ask those questions. So what question is there next? We were just interpreting the prediction for an individual right there, saying, like, here's what I think. I'm 95% confident that this individual's height will be between blank and blank. It's 474. You've got preference right now. Let's give preference to 474 for a moment. But Q48, you got it. Perfect time to ask that, Rose. And you can always ask beforehand. I'll try to keep it in my head. But perfect time to ask it. There's never, like, not a perfect time, but... Let's go check this out. Let's go to Q4H. Future Brian, label this Q4H. Here we go. And we got a lot of work, so I might just kind of work through this and talk through this sort of problem right here. Let's go, and you can search through all these files right here. Go down here. I named this one Brian earlier. Yours is probably not named Brian. Let's go to Q4H. Q4H. For each part, is this number 4? Number 4 right here. Let's see if I remember anything from spring. Awesome. Q4H right here. We're trying to find elements of a vector that are multiples of 5. Now, what's really great is we did something very similar to this, and don't worry. We did something very similar to this during class today. Q4H and Q4D, you got it. Let's do a little Q4H and Q4D. I'll put a break between these. So how could we check to see if something is like divisible by 5? Like if I just want to see is 5 divisible by 5? Like I just want to see if 5 is divisible by 5. Like anyone got any ideas to see if 5 is divisible by 5? There's a lot of ways to do this. I just want to see if 5 is divisible by 5. Or what is 5 when we divide by 5? Let's see what the remainder of 5 when we divide... Oh, 0. So how could I then logically check this? So we're just doing in those elements. You got it. Trace on the right track. And then how do I check to see if this is actually divisible? Because that tells us the remainder. So all this does right here, this will tell me what is the remainder of 5 when divided by 2, which is 1. What is the remainder of 5 when divided by 3 is 2. It's telling us the remainder. Like if you took 10 and divided it by 3, you'd get a remainder of 1 because it's going to go into it 3 times and have a remainder. We see some great answers going right here. So what we want to do right here is we want to see if this is logically equal to 0. Does everyone see right here? Whatever we put right here, like we take anything we want, any sort of numeric vector, like what's going to happen when I run this right here? Notice what you get. Look at the positions. Let's change it so the positions are a little easier to see. Look at where the trues are at. Where are the trues at? Where are the trues at in this vector? Go back down to it. Where are the trues at in this vector? Where are the trues at in this vector? Just look at where a true's at. Where are the trues at? And so this just says it's going to take this vector here and then tell us the remainders. You see there's 100, but 100 is going to convert to 0 because 100 does not have a remainder when you divide it by 5. And then we're seeing where the zeros are at. Does that make sense? Which is so cool. And then we could get the positions of these, yeah. And which we might do that. So we want to find what? We want to find for each part, print screen the result, running meeting of the requested elements of the ACT vector. Let me run all code above right here. You can run all code above right here. So there we go, the ACT vector. And so we want to go to we got the code right here. Let's just go here and let's do that. There we go. And now someone pointed out, we want right here to get these positions. That looks so horrible on the screen. We want to get these positions, and we go right here and go which. So now we just know if something is divisible by 5, and now we have the positions. Now here's where I break this apart. What do you think Brian's going to write before this? I want to make my life easier. This is getting a little bit cumbersome right here. So what do you think I'm going to write before this to make my life easier right now? I've been doing this a lot. So what do you think I'll write before this? You're on the right track, but I'm gonna I'm just going to put it into something first. Trace, you are correct. That's what we're going to do next. But I kind of just, since I have this, I usually store it. Yeah, I usually go right here and go, there's that. All this is just a bunch of numbers. Exactly, Trace. Great job right there. That just helps me break it apart, see what I'm working with. So that way the code doesn't get too nested. Nothing wrong with nesting code, but sometimes a little bit easier to just store this into an object and just be like, okay, these are the positions of the things I want. Well, guess what I just do then? I go to ACT, and what should I see here now? I should see the positions of the ACT scores that are divisible by 5. Does this make sense? When I see this, every ACT score should be divisible by 5. If it's not, I've done this incorrectly. And what do I see? Whoa, just, you gotta, wow. Is there a 35 in there? Woohoo! You don't gotta do that. There's the 35. I'm blind. It's just easier to do a check. I can find out which is the 35. So just going code within code, and 35's, there it is. There you are. You were hard to see with all those 5s around there. Great job on that 35. Okay. What do we do now? We'll do another one after this. What do we do now? We just want the... Probably going to be 25. I'll be shocked if it's not. 25. Because there's a lot of 25s. So, yep. Great job. Is it making more sense? Always do it in these little bits right here. Don't try to code the whole thing at one time. You can break this apart even more if you want. But think about what you want to do in steps. Think about each step right there. Great job, Trace and Timothy, earning everyone another 20 points. Thank you for following along, practicing, doing the code yourself. That's the way to learn it. If you just look to the final result and you say, what did Brian get? You just copy it down. You have to go through. You have to get stuck. You have to make these errors. I've done it a different way. Mohammed, drop yours in the chat real quick so we can see it. Feel free, especially if I ask you to drop code. And you can leave this one in the chat since we've already dropped the answer out there. But what way did you do it? There's a billion ways to do it. Let's break down Mohammed's way, and then we'll do the other question here from 474. We'll keep chugging along. Oh, I like this right here. Okay. Well, and so one thing we know about ACTs, which this isn't all right way, because what do we know about ACTs right here? And I'm going to break apart Mohammed's code a little bit. I'm going to call this, I'm trying to see where this ends. There's where that ends. What do we know about ACTs? What do you know about ACTs? Is there a 0? Let's say possible scores. Can you get a 0 on the ACT? I'm not saying you want to get a 0. I don't know if you can. I know. Yeah, they really do. And that's the thing is like I'll code things different ways. And really what we have right here, if you look at what we've done right here, if we break this apart, oops, I missed something. There we go. Ooh, what have I done? What have I done? Really? There we go. And then, there we go. I think that's the same now. So Mohammed went, and you could, I don't know if it's possible to get a 0. It goes from 1 to 36, yeah, so 0 is not possible. You could put in 0 there just in case. It won't destroy the code. And Mohammed did a %, which is good, because that shows us we're seeing if from the ACT vector, it's contained in here. So it's checking, like when we run this value right here, what will this return? This is someone's ACT score over here. What will this value return when we see, is it contained in possible scores? What will this return, just that last run of it right here as it runs through this vector? Like when this code runs with the %, what will this return right here when we see, is this ACT score contained over here? And it'll do it for all elements of ACT score. What will it return for the last one? So we should see at the very end of this vector, when it goes through this one and looks at this, then looks at this, looks at this, looks at this, looks at this, and it says, is the ACT score contained in possible scores? The very last thing it returns will be a what on this vector inside of here. So it's going to look at this on the last run of it and look down here. And it's going to say, is this contained over here? That will return a what? Always know what your code's doing. Well, the full thing, you are correct. The which, correct, Trace, you're 100% right. The which will do that then next. So you're very correct. This last element of what I have highlighted will return a true. So it's going to say true because 25 is contained in this vector. And that's what the % and % means, hence why I wanted to talk about this for a moment. This is going to say true, false, 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 true. So we should see true, false, 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 true. Let's run it. And we see true, false, 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 true. Does that make sense right there? How going backwards, you see the true right here and then the false is, and this occurs because 25 is contained down here, 28 is not, 29 is not. And then we go right here and we get the positions of the trues. We store those into positions. And once we have those positions, we look at the ACTs that are in those positions, and then we take the medians of those. Yeah, oh no, that's really great stuff right here. Just reviewing. Don't worry, Trace. 20 points. Keep those questions and answers coming. There's endless practice and endless review. Let's do another section right here. I'm gone. Brian has vanished. Brian is back. I think the other question was, which one was it? It was, did we just do 4D? No, we didn't do 4D. What does 4D say? The largest 10 values. Ooh, this is a fun one. A little more complicated than we would think. I'll give some hints here. Let's see what we got. Put on our chill music. Let's do this. So we want the largest 10 values. There's such a cheat way to do this one. Like, here's the thing. I wouldn't suggest solving things ways that are just brute force, but you could literally go to the ACT vector. Said you can't view it that way. Where's it located at? Which data frame? It's in the education data frame. You could go to the education. That might work. I have an idea. There's so many ways to do it. You could find the largest 10 and just write them down. It's not a good way of doing it. We're taking the median of this. Visually speaking, it looks to be 33. So we're going to take the median of this, and it looks to be 33. It's a good way to check. I think the answer should be about 33. It's not that hard to solve for if we solve it. Head, sorting the vector. Yep. So you can sort vectors, you can order data frames. We actually don't need to use the order. Yeah, I think Trace's way is going to work. Let's do it in steps. I do it the way Trace did it. So what we want to do is we want to first take the ACT vector right here. So let's go take the ACT vector. Let's just go take, because we've got to store it as ACT. No, got to store it as lowercase ACT. So we've got the ACT vector right here. Exactly, Rose, great job. And then we want to sort the ACT vector. This is not how you order stuff, it's just how you sort a vector. And then you want to go to decreasing equals true. Always take a look at what you have right here. And you've got right here the decreasing. Now, you could use head function, or you could just take the first 10 elements, and there's the first 10 elements, and then we go here to median of it. I did it too quickly. Oh, it's 33.5. Well, it was close to what I thought. It was between that 33 and 34, so Brian guessing at it would have been wrong. But if you look at the steps we did, make sure you view everything you're doing along the way. Did you sort your vector? Is it sorted the right way? Is your answer logical? What if Brian does this right here? What did Brian find? And just think, or I think you have to put decreasing goes true. Yeah, because I think it's... So what am I finding right here? I'm not trying to put wrong answers in the video, but I like where sometimes I go another way at the end of this, because think about what we have right here and how this would not be the right answer, which we could still obtain the right answer from this a separate way. I'm going to obtain the right answer from this. I wouldn't do it that way. I'm missing a parentheses. There we go. Ooh, what have I done? What have I done? Oh, median needs to be on the outside. There we go. There we go. Unexpected. There we go. For this one right here, the lowest 10, yeah. I wouldn't do it this way. With it sorted this way, we're taking the tail because the way the vector looks, if you look at the vector right now, the vector has the higher numbers near the end. So to get the higher portion, you would have to take the tail of the vector. So the tail of vector, just think of like a cat or dog, the dog. So the tail is going to be the end of it. I see we got some more 474. We can do it right here. Can you confirm all we have to do for the problem is subset and then the dimensions? Yeah, this is basically practicing a subsetting question. Trace, I can confirm subset approved right there. And is this making sense? Here we did some 474 pretty quickly there. 475 floor is open. 201 floor is always open. Tool 1 might get preference if a tool 1 or jumps on and says, hey, do this, explain randomness, explain sample surveys. Let's hop back to Spice. A little bit quick on that one, but it's all about that practice. It's all about thinking about multiple ways of doing something, the more ways. And I really like, and Charles Liu and Dr. Halafu and Dr. Liu, of course, both amazing educators. And I love all the positive support people give towards the other people in my department, because they really are like, they teach me so much. And especially Dr. Petrie, who I've known for such a long time. What's the difference between coding log and ln in question 1? ln does not work. Is this for 474? ln is not a function. Are you talking about the equations? Because you over 6f, so we don't have an ln. What do we do to get the log is we use just the log function that uses e as the base. There is no ln function in R. How do you use ln? It's just log, because log has base e by default. So log by itself is base e, which is natural log. Important thing to know right there. So there is no ln. If you want to go, you can change the base of the log function by going, thank you, Trace, right there. Awesome job. If you want to take a log of x and you change the base e is by default, so that's the default way the code is run. I should have put a 1 inside of there. Okay, we got 475 next. Let's take a look. So this is the default of it, but you can change the base. 5c. Yeah, we'll take a look at the next. Let's see here. We got some, what was it, 6f? Okay, and 474. Let's go look, and then we'll do another 475 next. Okay, let's go back. I think, so we'll go Trace, Hayden, and then Rose. Thank you, everyone, for being here. We'll definitely go a bit today. So, and I think I'm supposed to meet with someone later. They'll understand. Well, it's about class. They had questions. Let's do this. What is it? Could you 6F 474? Okay, let's look at that. I can't promise every time I'll be doing all the assignments, because a lot of them are more, especially like your group work and everything, which I do like that. Let's go look at the assignment. 6F 474. Oh, why am I doing that? See, even I forget. Let's go to Chunk Brian. Okay, Chunk Brian. Question 7. We don't want question 6F. Find the fraction of students whose college GPA is at least 3, so 3 or higher. Do this with a combination of wank. You're supposed to meet me. So, oh, thank you so much, Timothy. Thank you so much. Yeah, no, you know it is. So we'll make sure we meet. We'll meet here after this, because I think you were getting the Nestle's data set and it had an issue. Finishing 475, it came up with a weird install package in my output. Remove the installed packages. Installed packages will never knit. So take those installed packages out. Don't install your packages here. You can comment them out or just delete them out. Don't install packages. And if you're, send me an email or send me your RMD and I can get it to knit too if it has big issues. Please, please, please try to knit early. If it doesn't knit and you can't get it in, sad day. Find the fraction right here. Number of students whose college GPA is less than 3. Let's first find students who have a college GPA less than 3. How do we find... Let's just look at college GPAs. We want to first look at college GPAs. Who can help me just look at college GPAs? Let's just look at them. Nothing too big here. Don't go crazy. Just look at the college GPAs. Little bits. Let's just look at college GPAs. Let's just look at them. That's all I want to do. I don't want to do anything else. I just want to see college GPAs. That'll make me happy. Nothing too crazy here. Hey, what's up, Aaron? I'll be flying in for the start of the semester. I got that haircut. Trying to work out. So, education. Good to see you here, Aaron. I hope your semester... Are you graduating, Aaron? What's going on, man? Are you in the... What you doing, man? It's so good to see Aaron. Let's throw 20 points for Aaron appearing right here. I finally got that haircut. I got it like a month ago. Just started the MSBA. Congratulations. So glad to hear that. Congratulations. I am proud and honored. Aaron took... You didn't take 201 with me. 320, 474, and now I'm teaching 475 time series. So, Aaron, so good to see you, and I will probably be seeing you at the start of the semester. So I'll swing by, say hey. We'll open up my office for the first time in God, like a year and a half. Oh God. Okay. Let's see if people have a college GPA less than 3. It's been a while. Let's see if people have a college GPA less than 3. Or wait. Whoa. At least 3. At least 3. At least 3. I do too, Mohammed. We'll be swinging back by the office. We'll be back by... I don't know if we have a candy bowl or whatever. We'll figure something out. I've got a really fun thing excited with Nerf blasters for the start of the semester. I want to do a big data collection thing, which all my students, I know, I haven't even seen it yet. Great job, Trace and everyone. So I'm going to do a Nerf blaster thing. Blasters, not that bad G word, but we're going to do a data collection thing at the start of the semester. I want to maybe talk to like Campus Entertainment Board or something, bring in all my 20 to 25 Nerf blasters and have people collect data. We'll have like a QR code you can scan and you can enter in your data on the phone for each station. So each station will have a Nerf blaster and you'll like record how far it shoots. You can go play like go to an area and just be like, ah, and like, yeah. So we'll check it out. It's gonna be my send off to my Nerf blasters. I don't know, I'm old. There are dog Nerf tennis ball blasters. That is absolutely amazing. Let's go right here. We found out, how many do we want to find out? The proportion? Cool. Oh, we're almost done with this one. How does R sees trues and falses? How does R see true and falses? In the background of R, how's it seeing these trues and falses? Nice job right there, Connor. Great work. How does R see these trues and falses in the background? How does R see them? Very important thing to know. These are key things that you should be like, nice job right there, Zaid. Let's throw someone else some 20 points. So what could you do to a vector of ones and zeros? Like if you have a vector of ones and zeros right here, what could you just do to that vector of ones and zeros? What could you do to a vector of ones and zeros? So that is one way right there, Timothy. That's the long way. So, well, why would we do that? I guess, are we trying to find how many? What fraction? Oh, we're doing the fraction. Yeah. Oh, no, wait. Find the fraction. Yeah, it's really long if you do it this way. If you do which, you'll find the positions. If you do length, you find this right here. You find out the length of that vector. Then you'd have to divide by, you could divide by the number of rows in education, and we get the answer, and same answer. Much easier way to take the mean of a logical. So there's long ways of doing stuff, and there's short ways of doing stuff. So taking the mean of the logical vector, because this is how many people, this is which individuals are true, how many individuals. We could shorten this down by going here to a sum, and the sum is going to take how many trues there are. So that's still the same answer right there. Could you do, yeah, we'll do that. We got some ones lined up here. We'll keep working through. We'll probably go for another at least 30 minutes over. But does this make sense here? What's going on? We did a few different versions of this. Do not include all versions. You want to just get an answer. That is the goal. But there's 3 versions. I'd probably go for the more concise version, which shows mastery of the understanding that R sees them as ones and zeros. So great job right there. Let's head over to another question. Next question. What is it? Try to remember. So let's see right here. The next question was... I love the brute force coding. I love that. 6F, was it? Did we just do 6F? I think we just did 6F. And then the next one was 4C and 4D in 475. Okay, let's head over to 475 and do some question number 4. And then, was it 4C? Let me look at it. I think it was Hayden asked that. 4C and 4D. So this covers a bit of that, Muhammad, right here. Great questions. And let me get the 475 going. 201, if you ever feel free to jump in. I feel like I scare off 201. No! Okay. Let's do this over here. So we need to make a prediction for an individual that would be an extrapolation. This is a key thing, especially for forecasting. When you think about extrapolating, what does extrapolating mean? So when we do extrapolation right here, what is going on with extrapolation? What's the deal? What's the deal with extrapolation? What is the deal with extrapolation? Like, do you see any extrapolations in this model? Which I'll make a very similar one. I'll do height weight again. What's the deal with extrapolating? Yes, exactly. The x variables, it's on the x extrapolating. So when you extrapolate, it's on the x variables. You're going outside the x values in the data frame. So if we're outside of male and female, or if we're outside of weights about 90-ish to 305 or something, And so it's when you try to predict beyond your data frame. Now, this is key to forecasting because when we forecast, can I go back here to like the billions of models I created? There we go. Here's some ones. There we go. When we forecast, especially, does the viewer, hey, we'll forecast forward in time in the future. So we could create forecasts going forward. I wonder if I should have, go through all the plots I've created. Oh, I restarted R last night. I should have never restarted R. So yes, just going through here through different models we've been creating. Yeah, well, darn it. I didn't create that many models today. So we'd be forecasting outside or predicting outside the bounds of the X. So to do this, we need to create a linear model predicting someone's weight from their desired weight. So this one's a little more structured. Make sure you have Survey 10 loaded up, which means Survey 10 is inside of Reg class. And I also want to show what I just did, which almost would have broke it. A very common mistake right here is to break this. What do you notice went away? Brian just destroyed the what? What is the name for the thing Brian is inside of for 20 points? Doing this kills the what? It's dead. It is no more. What I kill, what I destroy is gone. No more. What's gone? You gotta be very careful if you do this. Ooh, that's bad. Ooh, that's bad. The chunk. And this makes it so the chunk does not end. This then treats all this as code down here. These backticks, which are right below your escape key, they're the tilde non-pressed without the shift key. The backticks end the chunk, look at the color coding, and then the X's go away. It's very easy to destroy chunks and create issues like this. So please watch out if that happens, and it won't knit. Sad day. So be very careful. Very easy to make errors like that. Happens all the time. All this good stuff right here. We're kind of covering a lot of 4 by doing this. So a lot of help right here in this video. We want to predict somebody's weight from their desired weight. I've got the autocomplete on. You don't. That's explained in the other question. Yours will not autocomplete. Mine will, because I attached, which sometimes I worry about telling people how to do that. Because I stored into the object M right here. Great job right there, Timothy. Excellent work. Just creating the y tilde x comma data equals. And now we want to make a prediction for an individual that would be an extrapolation. So we were talking about this earlier. If we want to extrapolate, probably something we should know, which would be good. Whoops, mine's, yeah, oh wait, did I do it correct? Predicting someone's weight. Yep, so this is the y variable from their desired weight. So the first thing you enter in right there is somebody's y variable is what you want to predict, and then the x variable is using the explanatory variable. Does the order, so yeah, it's y tilde x comma data equals, y tilde x comma data equals, y tilde x comma data equals. And yeah, great stuff right there. And now let's think about this. Probably we should understand where extrapolation occurs. We can visualize it if we want. I haven't visualized this model, classic visualization in Reg class. But what you could do is you could go to the range, which is a function I rarely use. And going to range, we want to see outside of our x variable, which interestingly enough is not the current one. And this tells you where extrapolation would occur. Extrapolation is below 95 and outside of 285. It's not the current graphic. You know what? Let's just show the current graphic. Why not? We're answering a good bit of this question. And the screen, one thing I've never really liked something about R is with those boxes. So the lowest weight that someone wanted to be was 95 pounds. That's the lowest individual. The highest individual wanted a weight of 285. So what would be a value of X that would be an extrapolation? Let's not go crazy. Like negative is ridiculous. I want to weigh negative 10 pounds. Okay, that's extrapolating our model. That's ridiculous though. The intercept is an extrapolation, which funny enough is the easiest value to get. 340, yeah. And watch this. I'll predict an extrapolated value here. An extrapolated value. Let me go to summary of my model. The prediction for the intercept is the person would weigh 15 pounds. That's the prediction for the intercept. Because I just went through and solved the model, and I'll show how this is going. All R is doing when we use the predict function is it's going to make predictions for individuals using the mathematical equation this model creates. Let's look at the mathematical equation just real briefly right here. The mathematical equation is somebody's predicted weight is equal to, so their predicted weight, great job right there, Mohammed, excellent work. their predicted weight is going to be equal to the intercept plus their desired weight. I guess this is one way of doing it right here, the quicker way, times their desired weight. So I'm going to predict my weight right here, and all I have to do is put in my desired weight. I want to weigh, I don't know, 172. I don't know what I want to weigh. And now I can look here at my weight. I got to be careful. I'm storing so many things. There's my weight right there. Might have just caused some problems with the way my model is created. We'll ignore that. Hence, never attach things to the global environment. Causes issues sometimes. But let's see if this is correct right here by going to, and so you could just run this right here and just put in a prediction. And I think someone said 340, do 1,000. So we should get 240. Influence plot, yep. Great job right there, Timothy. Influence plot for the other parts. See if a point has undue influence. Sorry. So now, let's do it the longer way, which for more complex models is going to be easier. For a simple model, writing the equation might just be best. We're going to go here to new data, ND. That's just a name. That's just a thing I'm calling it. We go through this a little more in depth earlier. And we're going to store right here in the new data frame, we're going to have a variable desired weight. Key question, why am I putting desired weight right there? Why is desired weight going into this data frame, which will be then used to make predictions for my model? Why is desired weight going in? Great job right there. And why is desired weight going into this new data frame? I'm going to put 340 right here. Why is desired weight going right there? And the answer is right above it. Why is desired weight? We're predicting weight, and then you're right. That makes, and desired weight is the X variable. So this is, and you could put multiple values right here if you can concatenate it. And so we have the desired weight of 340, and we can make predictions. We could make two extrapolations right here. So we could do a low end extrapolation and a high end. And now when we make predictions, we don't want to predict for everything, which this is everything. We want to predict for new data. I hate that doesn't autocomplete. And there's our predictions. So the person who desires to weigh 80 pounds, that is their X variable, if you notice this is the X variable which is going input into the model, is predicted to weigh 90.32. The person who wants to weigh, desires to weigh 340, is expected to weigh 334. We can check this right here by just going back here, and we don't need to store it into weight. We can just solve this. We could go right here and just put in the value, and you can see what it's just doing this work for us. We put in 80, and there's the answer right there. And we put in 340, and all it's doing is solving these equations. Does this make a little bit more sense to understand what R is doing in the background? You don't need to use the prediction interval because that'll get... We're just doing the predicted values for this question, I believe. I'll double check. I wrote it last week. But all R is doing for you is going through and solving the equation. You're just feeding into it the X variable. But this would be really easy if you wanted to make a vector of predicted weights right here, like 1 through 500. You could go right here and get all the predicted weights like this. So here's the predicted weight for every single one of these. You could be like, oh, you want to weigh 200 pounds? Well, then here is your predicted weight if you want to weigh 200 pounds. Oh, you want to weigh 150 pounds? Well, here is your predicted weight. And if you want, stream buffer, second time today, happened during one of the classes. Hopefully YouTube's not being weird or Suddenlink's not being weird. Little stream buffer here and there happens every once in a while. I hate that it happens twice in one day though. But is your viewing? Huh. Never noticed that. I hate buffers too. Sorry about that. It's just one of those YouTube things. We all back. So yeah, it shows it on my end sometimes. I prefer it when it shows it on my end. So sometimes people will be like, you're buffering. Maybe that was a Knoxville issue or something because there was every once in a while issues. So that goes through that right there. Let's take another question or two. So we'll put a cut in the video. Whee! We're back. What questions are there right now? Throw another question my way. Let's put on Smooth Chill. Your time to ask questions. Let me know which questions you're working on. For R-squared interpretation, can we use... Yeah, of course. Mohammed, definitely. You're welcome, Hayden, anytime. Great job, Hayden. By the way, I had never seen Visual Markdown Editor until today. Very cool. Exactly. And show me things because literally so many things are added that I'll miss things. And there's just so many interesting things you can do, and it makes it way easier to edit a markdown. You're just like, it's just like a Word document then. Like, I'm like, treat it like a Word document. People are like, this doesn't look like a Word document. And then you go over there and click the visual markdown editor, and you're like, oh, now it looks just like a Word document with bold and italics and insert. You know, it's just, then it's exactly like it. X is the percent of variation in weight explained by the variation in desired weight. Blank percent of the variation in ways explained by the variation. Yes. Exactly. Yeah, or it's unexplained. It's the unexplained. Like, there might be other variables. We can't say that they exist, but there's unexplained variation. Yep. Perfect, Mohammed. So we'd say, and that's actually the coefficient of non-determination. 1 minus r squared is the unexplained variation. And it's from the mean of y. Like, if we go back to some 320 with the naive model and the sums of squares and all this. Could you go over some hints on 5? Of course, Rose. Oh, look at that trace and everybody. 5C. Ooh, what the heck is 5C? I don't even know if I can solve 5C. You guys are scaring me. What have we done? It's weird. I don't know if it's the way this sits in my ear. Note to self: get new headphones. Now it's like too loud. I got this fear I'm going deaf. All right, let's go to 5C. I talk to myself. 5C says a frequency table showing how many columns of education are integer, numeric, and factors. So what we want to do here is check a column. Let's just do this for one right here. 42 is the answer. Timothy, don't give away answers, man. Don't tell them. Don't tell them. So right here, a frequency table showing how many columns of education are integers, numeric, and factor. So with this right here, let's just check. I mean, we can see what's going on right here. Let's go here. Let's look at that education data set. Okay, that's got a lot going on in this education data set. And we want integer, numeric, and factors. Talking some Hitchhiker's Guide to the Galaxy right there. If you didn't get the 42 joke. Sorry, I ruined the joke right there. How can we check how R sees one of these columns? How can we check how R sees one of these columns? How could we check how R sees one of these columns? How could we check how R sees one of these columns in the background? Like how R's like, oh, this is how this thing exists. This is what this is. This is how I should handle it. This is what I should do certain things, class. So let's go here to class, education, and let's go to this. Ooh, that's numeric. Got some warnings. Go away warnings. We don't want you here. Oh, that was from previous code. Oh, because I ran this. You're weird, R. So at least I can get on the right here. Oh, you can, yeah. Good references right there. Timothy, 20 points for some references. Classic. With this right here, we are now wanting... There's so many different ways to do this. There's way harder ways to do this. But data frames can be treated like lists. And I feel like my teeth are just weird because of the... Yeah. There's probably easier ways. But how could we run this function repetitively over a data frame? How could I run this function repetitively over a data frame? Like, almost like apply it. Like, what would be a good idea here? Any ideas? Don't put the full thing yet. Don't put the full thing. I could do that. I would, yeah, you could loop it. The looping way is going to be a lot harder. I'll do the loop way really quick. I think I can code the loop in, put a little HackerMan on, do a little loop right here in a second. It's way tougher. lapply is a function that applies a function to a list. It looks more complicated than it is. All this is right here is the first element. It's the list. So the first element's the list. And we go right here. So we put in education. Autocomplete hates us. Autocomplete, where you at? You gone? It's okay. You're going to do your thing. And then we run the function we want to run. Now, what people are pointing out is this returns a list, but I'm going to go here to sapply. Makes my life easy. We talked about sapply and lapply in class today. If you want your lapply to not return as a list, you need to take your lapply and unlist it. The way lapply works is it's meant to take a list, which a data frame can work as a list. And yeah, an lapply is going to be 1,000 times easier, or sapply, which is smart apply, which generally looks at the object you take and tries to return something of similar form. For loop stress me? Well, there's going to be some stress here coming up next or later this week. Sorry. And then, oh, what have we done? What have we done? Unlist. There we go. All we want to do now is take this object. We'll store both of them into X. Be very careful. Look at your code. Look at your output. I don't always clean up what I do right here because I show examples. But all you want to do now is just take a table. And yeah, that's it. There's 18 total columns. And where were we at? We were at the education data frame. So there's 18 total columns that have the following format. The for loop way is a lot harder. Let's put on a little hacker man right here. Oh, I could show something new. Ooh, does it work on this screen? Let's put a 1 minute timer on the clock. Let's see if we can hacker man this. Does this screen work with this? Oh my gosh, it works. I made something new this weekend. Here we go, hacker man time. Let's for loop this. Okay, so we want to go to class of education. We want to put in a placeholder of the first column. There it is. We want to go here to store. We're going to store into here position 1, and we'll store this into it. And now this will loop through. This will become I. We need to create the store thing before we do it. Store a blank vector in it. I'm going to go here to 4. Store into this. And then we want to go right here. We're almost there. Oh, we need to put a factor around this. All right, there we go. Now we go here to oh, we're running out of time. I in 1 through 18. Run it. Table. Store. No! Thank you. I worked on that this weekend. What do we do? We're so close. Something's going wrong here with this. Okay, that's... Are you the problem? Position I. What? I should be changing. I is 18. Should I not put this around it? Literally during the end credits, I can rewrite the other one. Awesome. Let's do some new stuff right here. Well, thank you. Yeah, I'm wondering why I'm a little bit confused about. Theoretically, I'm just trying to think through what the for loop didn't do correctly when I had the factor around it. Petrie would be like, Brian, why'd you mess that up? Way more work to write that for loop. The for loop isn't that big, but it's just, you need all this right here. Don't write the for loop version. That's way too much. And that's just some example work. Yeah, so right here we got this one line of code. S applies way better. And theoretically, I should probably have n row education right here, or ncall of education data frame. And that will return that. And so theoretically, I shouldn't put a number in there. I should put the value. Do your best. It's all work out in the end. I'm just working. Okay, so then we got some questions about 6.3. Arrow will head back to Sploce, and they'll do another question here. Great work right here, everybody. Starting early. Remember, it is just practice. You need some time to sit down with these, sometimes to look at these, some time to practice. The earlier you start, the better. You want to get stuck, and then you want to get unstuck. That's how we learn. You have to get stuck. Let's look at some 3. Here we go. 3C and 3D was it? Okay, let's do those. Let's head to the main screen. Let's put on the music. Chill out music. This one right here. Let's do this. Okay, compare the values of weights for right and left-handed people. Clearly interpret the results. So we're going right here, we're going to throw a chunk in. Chunk. Boop. That's the plus icon right here. The great way to throw in chunks makes life nice and easy. And we want to look at the weights for right and left-handed people. This is from Survey 10. Of course, what other survey would it be from? And there's a lot of ways to get to these. But let me check that out here, Timothy, in a second. I thought I had it open. Oh, yeah. Yeah, I think I'll have that posted later tonight. I'm just trying to make sure I know where we get to. Last thing I want to do is put way too much work on it or way too little. Better to put way too little work than way too much. I've conceptualized it. I just haven't formulated it. So one of the beauties of teaching class for the first time. So many ways to do this right here. Should we do the hard way first or the easy way? The easy way is less learning. The hard way is more learning. What we could do is we could remove the ambidextrous people. Ooh, we got some good stuff right here. I like this. Let me take a look. Thank you, Timothy, right here. You can share code right here. He's made 2 subset, it looks like. Let me take a look. I'll show the easy way after this. Okay. Subset, creating of... Let's see right here. Okay, there's your left-handed people. Okay, wait. I'm confused. Time to apply non-function. I've got something too much here. Well, here's your subset creation. Or is this going here? Wait. Subset. Oh, you're putting the lines in code individually now. Okay, so the first line of code is creating... Oh, I kept mean on there. The first line of code right here, I don't know. You might have it. I'll take a look. The first line of code right here is just creating a vector of handedness. I wouldn't necessarily call this a subset. This is storing to the global environment a vector of handedness. And then, but you do have your left and right. Okay, I see. So you are finding, there you go. You're saying you're finding the which I see right here. Yeah, it looks like you might have it. We'll see if we come to the same answer right here. So what you could do is you could go right here. Let's just create a subset of people who are only left and right-handed. So let's go right here and go to left, comma, right. Does that make sense? And then let's just call this sub. From here to life gets easier. I just named it random. Yeah, and then you can get the means right there and then compare the means. Yep. And so here, there's about 1 billion ways to work on this. One of the easiest ways, now that we've created our subset of just left and right-handed people, probably one of the easiest ways is with the associate function now. And the associate function from 320, which is one of the things I wanted people to think about with this, is we can just go right here and compare the weights, weight of handedness, and then we just go to sub, and currently, need at least 2 observations to proceed. What's it mad about? Let me look at my sub data set. Oh. Really? Oh my gosh. Wait. Oh, I see what I'm doing. My brain is not working. Well, let me do it in 2 steps. These are the positions. So what am I going to write after this? Take a moment. Pause right here. I'm going to zoom in so you can see really well. What am I going to write? I just found the positions of the individuals who are right and left-handed. Don't worry about that. I just found the positions of the people who are right and left-handed. You could put a which around it. It'll still work as a logical vector. How am I going to create the subset right here? There's about 1 billion ways to create subsets. But how could I do this right here? What could I do right here? Ideas? What could I do to create my subset? Because I found the positions of the people who are left and right-handed. So I know the positions of the individuals. So what would I throw on there now? What am I throw at the end of this to only get those positions? Because I only want those positions right here. Is that close to me? You're super close. Make sure it's 2-dimensional. So I'm using a 2-dimensional object right now. Braden, great job right there too. Let's throw some more 20 points. Oh, what's it mad about? Oh, naming conventions. That's what it's mad about. Make sure to throw the 2nd dimension on there because I'm working with the data frame. So there we go. Points. You know what I can... Sure, I added 100 by accident. So the 2-dimensional, so big points right there, crazy points. Okay, now what makes life really easy, and you can get some cool output on this, is you can run the associate function. Now it runs, thank you, associate function. And the associate function is going to give you all this fancy output right here, and we'll make it smaller so we can kind of see what's going on. And we're only looking at the weights of left and right-handed people. Now, we don't really see any difference right here. Here's the difference between the averages. So were you getting the following values right here of left-handed people weigh this, and right-handed people, you know, we just weigh so much more. I can't promise the points won't get that crazy. The points have always changed as time goes on and how they work. They won't get that crazy. So showing up to office hours is a great way to get points. Being in both classes, not that I intended it, but I can't somehow break up how many bot tracks points. But you should see these values right here for the values. Another way, which I always like showing some dplyr, is to go to survey 10, and we might be able to do this pretty easily, is to pipe in the option to go to let's go to group by handedness. And handedness is going to, hey, thank you. And then we're going to go right here, and we're going to go to summarize. Really? Summarize, and we're going to summarize weight. Or we'll go, yeah, sure, we'll go weight equals to mean of weight. And that should work. There we go. I don't like how many decimals it annotated. Is that? Yeah, it is showing it by there. I wish it showed a little bit more, but it's rounding. It'd be close enough. And technically, since this is returning a tibble, try this. It doesn't like that. I probably need to store it. It's the only time I use right arrows. There we go. And so we see about a 6-pound difference. What is the best way to interpret this? Well, what do you see? Let's look at what we see right here. Compare the weights. Yeah. I mean, just think about it. I don't really like how this is rounding it. Let me try. I don't like how. Why is it rounding it like that? I'm going to just try and interpret it in the chat real quick. What do you see? What do you see? Really, Tibble? Tibble, stupid Tibble. What is the best way to interpret this? What does it mean? Who knows? Oh, now it wants to report all the values? Really? Really? That's what we observe. The differences are probably due to random chance. I mean, you don't have to go into that because it doesn't talk about a p-value. But I would say, you know, in our data set, we observed this. We did observe this in the sample. Probably a good word to use right there, that we observe that in our sample. Like, we're not going into in-depth interpretation on this one, but if you look at the statistical report on it, the difference observed is probably due to random chance. I mean, it's likely. It's a p-value above 0.05. So this difference we observe of 6 pounds is likely due to random chance. That goes above and beyond on the interpretation, but we're just looking at here at the difference to see, and really, it's not that much of a difference, and it's just random fluctuations. It's just that some right-handed people happen to weigh more, some left-handed people happen to weigh less. Maybe there's a difference. Maybe right-handed people are just like, I don't know, eat more. I don't know. I mean, it's how you generally weigh more as you eat more. And there's a correlation between eating and weight. Calories in, calories out. That's how it works. So good stuff right there. He'll put a cut in the video and we'll go back and do some 3D. Let's do this. I should have like a 3D thing that's like, whoa. So let's go over here. Yeah. Oh, I can't do it. What would you think? Let me try something. I want to hear people's thoughts on this. Let me take this. This is a horrible idea. I'm going to crash Streamlabs. Brian, your things are working. Why are you doing this? I want to know what people think of this. Not yet. Let's try something new right here real quick. Tell me if you like this better. It's not there yet. 2 seconds. There we go. We're getting there. Better, worse? Hey, Trace, have a good day. Better or worse? What do you think? Do you like it better than the last one? Do you like it better than the other space? Like, which one's better? This or the new space background? This is more like space, actually. I always talk about going to space, and I call this space. You like it? It's pretty. Maybe I'll keep this on here. I should turn off my other background. Where's my other background? 2 seconds. New background. Yeah, there it is. New one is awesome. Cool. Maybe I'll keep it. I was experimenting with some stuff for the weekend, trying to get some things going right here. People seem to like the new space background, so hey, we'll use it. Just up here in space. It makes more sense when I say space now. It's like, hey, I'm here in space. And I've got some pretty other fun stuff. Just working with some new assets this weekend. This one has a better loop too. Hopefully it's smaller, works better, doesn't crash as much. You don't want space to crash. Let's go look at some 3D. Let's do it. We got our new backgrounds, all that great stuff right there. Hopefully it's not going to crash. I actually crashed Streamlabs last night. I was like, what if it won't work tomorrow? I was like, well, we'll figure it out. We'll just say like, hey, here's the Zoom link. Yep, great job right there, Zaid. Great answer. 20 points. Checking in the chat. It's ABS. So you are correct. Run the associate function on 2 categorical variables on your choosing from any data frame outside of survey 10. So guess what that means? I'm going to do survey 10 here for this example. Load another data frame, so you have to know how to do that. Compare 2 categorical variables. Explain the result to someone who doesn't understand statistics. Okay, let's look at this. So the associate function is amazing. It's one of the quickest ways to look at variables. My associate function right here, it's not mine. Don't want to imply that at all. The associate function I'm using right here is going to compare and see if I can explain someone's handedness, because that's the Y variable, to someone's gender. So does gender explain someone's handedness, which is a ludicrous thing to say, oh, you're right-handed, you're male. Or you're ambidextrous, you're female. What? Don't get it. I don't get it. The formula is y tilde x comma data equals. Both of these are categorical variables. I have them stored to the global environment right now, so you can see right, left-handed. They are factors. And so we do confirm we have 2 categorical variables. Which thing weird? And check out what we get. What's that? Who knows what that is? I gotta change what this is called. Who knows what that graphic you just saw is? That graphic up there. What is it? What is that graphic up there? What the heck is this? Thoughts? What is that graphic? Answers down here somewhere. What is that graphic called? Oh no, no one knows! Tiny Puppet Shark, do you know? He knows it. Tiny Brian, do you know?
I don't know anything.
Oh, Braden knows. Great job, Braden, right there. It's a mosaic plot. Mosaic plot's like a mosaic of pictures together, but it's just the areas by which these individuals, you can see there's a little bit more females in the data set than males. This is the marginal distribution of handedness, because on the margins, there's more right-handed people as we would expect. Males are a little bit more right-handed than left-handed than females. Males are a little bit more left-handed than females. Went against my theory, random theory. But down here on the bottom, love to see the mosaic plot exactly. And then down here on the bottom, we have the p-value being calculated. The p-value is the probability of our results or results from our stream happening by random chance, given the null is true. We talked about this at the very start of Office Hours. We're talking about Brian running a mile right here, and we'd expect if he's a 6-minute mile runner to run around here, but we observe something way off to the side. This works the same way. This time we get a distribution of results right here, where we expect the discrepancy to be very what? What is the expected discrepancies between the levels? Like, males have this much right-handedness, females have this much right-handedness. The expected discrepancy between the levels is expected to be very what? Hence 0 is very, very what? We expect the discrepancy, which is weird because this is not the center of the distribution, but it's the what we would expect by random chance given the null is true. It's the most likely thing. The most likely thing to see given the null is true is this. Well, this is the most likely result, and that's when the mosaic plot looks very lined up. If the mosaic plot were to look very lined up, we'd get a value close to 0, because then there's really no discrepancies. But if there's large discrepancies, you would say that these discrepancies are very what? Oh, they're not... Mohammed, 20 points right there. Throwing a knot on top of that. These are not points. Look at the start of it. These discrepancies over here on this side are ones that are unlikely by random chance, meaning small p-value. So you can see right here, the p-value would be the area shaded to the right of this. So our observed result is the line itself, And then the p-value is going to be the probability of our observed results or results more extreme happening by random chance variation, given the null is true, and the null is that there's no association. So in this instance, do your results look plausible? Like, given there's no association, do your results look like there would be? Like, do your results confirm that? Do your results go along with the idea of there being no association? You're like, whoa, my results are very different. Do your results go with the idea of there being no association right here? Just look at your results first, and then look at the p-value, which kind of confirms what this graphic looks like. The graphic might trick you at times, so the p-value is the answer if your results are likely or unlikely by random chance. So what do you think? Do your results look by random chance here? Like, I mean, there are differences. Males are more right-handed, males are more ambidextrous, but these differences are very small. And that doesn't mean they are or are not by random chance, because sample size comes into play. But the graphic can give you an idea, because the differences are very small, and small differences are what by random chance? They are like, yeah, smaller differences are more likely by random chance. If there was no difference, i.e. they lined up perfectly, the red line would be here because there'd be no discrepancies between the marginal and conditional distributions. Like, we would see the same amount of left-handed males and the same amount of left-handed females. So the p-value down here is the area shaded to the right of the curve, which is 73%, or we're doing it via the permutation procedure, or 73% of our random permutations, which is how we calculate p-values, were as extreme or more extreme than our observed result, which our observed result had a discrepancy of 0.639. So what does this really tell us? It basically tells me, and I mean, I'd write a little bit here. I wouldn't write just this. But how could you summarize this in one sentence? Who knows in the chat how you could just summarize this in one sentence? I'm not saying just write this. I mean, you can give a little bit of interpretation, but I want to make sure you understand what you're seeing right here and you could tell someone about this. A lot of the point of what I try to teach is like, could you tell someone what the point of this is? Like, what's the whole point of this? Because you can say, like, I could be a stat person here. I'm gonna talk stats while someone tries to tell me what's the whole point of this, which you probably want to do more than just the smallest of things. You want to make sure it's clear to somebody. But if I'm a stats person, I would say, well, the null hypothesis would be that the conditional and marginal distributions are equal between males and females' handedness. And here we see a discrepancy calculated by the chi-squared test statistic of 0.63985, excuse me, right there. And the chi-squared test statistic took the sum of the cell chi-squares, which was calculated by the observed minus expected squared over expected, which is going to tell us like what we expect as a discrepancy. The expected is the row total times column total over grand total, which gives us basically the mathematical computation of when two things are independent, what we would expect by random chance. I'm talking like a stats person here. I don't know who this is, but I'm Nicolas Cage. And when we get this p-value right here, the p-value is going to tell us if our results or results more... Maybe I'm Bernie Sanders right now. I don't know what's going on. The p-value is going to tell us if our results were likely... But what's the whole point? What's the whole point? No one's told me the point of all this. Stats person, you're hurting my head. What's it all mean? I can tell you what it means. I can explain it to you without going stats. But be careful. You want to give a little bit... You want to make sure it makes sense. Don't just throw one sentence and say, p-value high. P-value high? I can see that. Is that high? That's very small. It's less than 1. I don't know the range of p-values. What does this mean? To make your hands crossover right there. Probably worst impressions ever. Could end up on some live stream fails right there. What does this mean, Muhammad? I might have to leave it. I don't know. Well, there's a small difference between genders, between their handles. Yeah. And so, Braden, I like that. And maybe, Braden, that's great stat understanding right there. Great stat understanding. So I'd maybe even so I'd keep it at that, Braden, and then maybe throw on a little bit and just be like, it looks like gender has nothing to do with handedness. Like, if you knew someone's gender, it would tell you nothing about if they're left, right, or ambidextrous, because it's just random fluctuations. Like, yeah, there were a little bit more left-handed males, but that's probably just... You collect data from 699 people. Sometimes there's a little bit more left-handed males than right-handed males and females. It's just random fluctuations. There's nothing going on, as far as I can tell. Knowing someone's gender would really tell you nothing about their handedness. Does that make sense, Braden? Like, if I'm talking no stats right here, I'm not stats person anymore. I'm just regular old Brian. And I'm like, yeah, gender really has nothing to do with handedness, as far as we can tell. If it does, then we didn't figure that out here. You know, if you know someone's gender, knowing someone's handedness would just be the same as just guessing, oh, you're right-handed, because most people are right-handed. Knowing someone's gender is not going to give you additional information. I think that's even better right here. Like, it's not going to help you out in figuring out someone's handedness. That's probably my last. If I'm given one last thing here, knowing someone's gender would not give you any additional information about predicting their handedness because they're not really associated. Handedness, most people are right-handed. Knowing someone's gender doesn't help you out, even though there's small differences. And so once again, I would kind of throw in, Braden, I think that's great, and that would just tack on that sentence. Let's hear. Puppet Shark is about time to end. He can't say no. Maybe we should make one where he says no, but then it wouldn't be the actual voice. Thank you for not copyright claiming us, Puppet Shark people. You're welcome, Mohammed. We're back here in our new space background, our new spaceship. I need like a spaceship. Maybe I'll make that. I don't know. Did a lot of work this weekend. It's a great time to catch up. Oh, I'll send you a call. So let me hop off here, Timothy. We'll hop on here on the call. So we're going to end office hours now. Great job, everybody. I got 9+ messages. We'll have some lunch here. Hopping off here. We'll be back tomorrow morning. Email those questions. Work with your group. Let me know if there's any issues. I'll see everyone here soon. Bye for now, everyone. Bye. Bye, Puppet Shark. Tiny Puppet Shark.